Hi, my name is Alex Arrieta. Today, I'll be solving question 5a and 5b from the third problem set in connection to the kinetics chapter. Let's start with question 5a. Firstly, let's analyze the information that we're being given with question 5. So question 5 states that the decomposition of a hypothetical compound, xy, is second order in xy, and has a rate constant of 7.02 times 10 to the negative 3 inverse molar per second at a certain temperature. So, for the sake of better organization, let's underline the rate constant, K. We also know that this reaction is second order, so let's underline that as well. Now with this information in mind, we can go on to analyze question 5a. Now 5a reads the following. What is the half-life in minutes for this reaction at an initial concentration of 0.100 molar? In order to solve this question, we'll strategically divide our problem-solving steps into 3 steps, with step number 1 being collecting and organizing relevant information, step number 2 being inputting our information into relevant formulas, and step number 3 involving doing our calculations and double-checking our answers. So our first step here will be to organize all of our data and find the relevant information that will allow us to solve this problem. So we know that the rate constant, K, is equal to 7.02 times 10 to the negative 3 inverse molar per second. We know that this is a second order reaction and that we have an initial concentration of 0.100 molar. These are the values that we're going to use to solve this question. Now this question is asking us for the half-life in minutes of this reaction, and we know that it's a second order reaction. Using this, we can go back to our formulas for the half-life of second order reactions and find that the half-life formula for a second order reaction describes the following, where the half-life of a second order reaction is equal to 1 divided by the rate constant K multiplied by our initial concentration. So now we have our values, our variables, and our formulas. The second step will be to input our values into our given formulas. So we know that the half-life of a second order reaction is equal to 1 divided by the rate constant K multiplied by our initial concentration. And we know that our rate constant is equal to 7.02 times 10 to the negative 3 inverse molar per second. We also know that our initial concentration is 0.100 molar. So now, we have inputted these values, and we are ready for step 3, which is doing our calculations and solving for the half-life. So first, we are going to multiply K times our concentration, which gives us a result of 7.02 times 10 to the power of negative 4, with our units being seconds. Now let's input this back into our formula. Doing our calculation, which is 1 divided by 7.02 times 10 to the negative 4, we get an answer of 1,424.5, or 1.4245 times 10 cubed. Here, our units are in seconds. However, since we need this in minutes, then we need to convert this using a conversion factor. So we know that 1 minute has 60 seconds. So if we use this conversion factor and we divide 1.4245 times 10 cubed by 60, we get an answer of 23.7 with our units in minutes. Thus, the result for question 5a is 23.7 minutes. In this way, by collecting relevant data and identifying the order of a reaction, inputting our data and doing our calculations, we have solved for the half-life of a second order reaction. Now, let's move on to question B. Question B reads the following. How long will it take, in hours, for the concentration of XY to decrease to 12.5 of its initial concentration, when the initial concentration is 0.200 molar? First, our first step will be to analyze the new data we've been given. So, we have an initial concentration of 0.200 molar, and we are still dealing with a second order reaction. And we are asked how long it'll take, in hours for the concentration of XY to decrease to 12.5 of its initial concentration. Now, if we turn 12.5% into a decimal, we know that 12.5% is equal to 0.125. Now, if we multiply 0.200 molar times 0.125, we know that the concentration we want to get is 0.0250 molar. This is the value that we're going to use to solve our problem. Now, we know from the information given to us that this is a second order reaction, and using that information, we can find the formula for the half-life that integrates both the initial and the final concentrations, which describes the following. For second order kinetics, 1 divided by our final concentration is equal to a rate constant, K, multiplied by T, plus 1 divided by our initial concentration. With this in mind, we can go on to solve the problem and move on to our second step, which is inputting our values into our given formulas. So, 1 divided by our final concentration is equal to 1 divided by 0.0250 molar, which equals our rate constant, K, which equals 7.02 times 10 to the power of 3 inverse molar per second, times T, plus 1 over our initial concentration of 0.200 molar. So, 40.0 molar is equal to our rate constant K of 7.02 times 10 to the power of 3 inverse molar per second times T plus 5.00 molar. And if we rearrange for T, we get that T equals 40.0 molar minus 5.00 molar divided by our rate constant. Now, let's finalize the question by moving on to our third step, doing the calculations. If you let this run in your calculator, you'll find that T equals 4.9858 times 10 cubed, with the unit here being seconds. However, we know that the question is asking for this value in hours, so we need to set up a conversion factor. So as we know that 1 minute is equal to 60 seconds, we'll put it alongside it. And since we also know that 60 minutes are equal to 1 hour, we'll also put it there. If we let this run in our calculator and do our conversion, we'll get an answer of 1.38. And since we've done our conversion factors, we know that this is in hours. And so, our final answer is 1.38 hours.